Given a quadratic equation ax squared plus bx plus c, we can use its discriminant delta, which is b squared minus 4ac, to determine its root classification. For example, if delta greater than 0, we know there are two distinct real roots. But if delta equals 0, the equation has only one real root with a multiplicity 2. If delta less than 0, the equation doesn't have a real root, but has a pair of complex conjugate roots. Now, for a polynomial equation of any degree n, can we figure out a similar discriminant system so that we can determine the root classification of the given equation without actually solving it? The answer is yes. The theory and algorithm has been published in the Journal of Symbolic Computation in 2009. Today, we won't talk about this theory and algorithm. Instead, let's look at the implementation. So, let's restart the Maple and then load the program. The first example is a quadratic equation, x squared minus 4x plus 3 equals 0. You know, it has two real roots, right? 1 and 3. Let's see. Yes, we get two distinct real roots with multiplicities 1 and 1. No complex conjugate roots. Next, let's look at the cubic equation. Oh, it has one distinct real root with multiplicity 1 and a pair of complex conjugate roots with multiplicity 1. It is true, right? Now, let's look at a big polynomial equation with degree 14. Then we use the program to see what happened. Oh, we get three distinct real roots with multiplicities 4, 2, 2, and one pair of complex conjugate roots with multiplicity 3. To convince you, let's factor the polynomial. Oh, it turns out C1 is a real root with multiplicity 4, yes. And here you can see the delta greater than 0. So it has two distinct real roots, but because the exponent is 2, so the multiplicity would be 2 and 2. For this quadratic, the delta less than 0, so it has a pair of complex conjugate roots. And because the exponent is 3, so the multiplicity is 3. Finally, let's look at our target, the degree 10 polynomial equation. So let's see the root classification. Oh, we get two distinct real roots with multiplicities 1 and 1. And four pairs complex conjugate roots with multiplication multiplicities 1, 1, 1, 1. Actually, you can look at the graph. See, there's two real roots.